Final project and techniques of metallurgy. Reporter, Genian Los Angeles BS Mining Engineering. A classical methods of analysis. First, copper assay. Second, lead assay. Third, zinc assay. Fourth, iron assay. B. Instrumentation methods of analysis. Extraphotometry. Second, X-ray diffraction. Fluorescence. Third, microanalysis. Classical methods of analysis. Copper assay. In modern mining fields, the far assaying copper is replaced by the volumetric or electrolytic methods, both of which have been given expectedly like superior methods. The ore taken for assay is a clean sample of copper pyrites or copper matte. Copper assay method, the sulfuric in the ore or matte is eliminated by roasting. The oxide thus formed is reduced to metallic copper by fusion with potassium cyanide. Apparatus, the usual scale and furnace for roasting and fusion, briquettes and miller. Reagents, ammonium carbonate, charcoal, borax, glass, potassium cyanide. Details. Within duplicate 10 grams finely powdered ET-save or matte, carefully roast as before described, remove and mix with 1 grams ammonium carbonate, re-roast, remove, mix with 1 grams. Charcoal, re-roast, remove coal with mix with 30 grams, KZN and 3 grams borax glass, place in a number 5, hidden crucible, and cover with 10 grams KZN, then with salt. Use in a bright red file for about half an hour, removes and pour the charge. Cool, collect and weigh the copper. Calculation, accuracy, etc. The result multiplied by 10 gives the percentage of copper. With clean mats containing number, autonomy, lead, etc. Results accurate within 2% may be obtained still unless the exact nature of the mat be known. This method is too uncertain as the before remarks must give place to another, more accurate methods. Lead assay, first method, soda, argol and meals. First, apparatus, the wine furnace, pulp, scales, crucible, etc. Reagents, soda, carbonate or potash, argol salts, meal or nails or wire. Third, details of operation. The ore clean galena as reduced sample and an assay sample obtained which has passed throughout the ET cell. Wade through mix the chains on gloves paper and transfer them to the crucible F. In each crucible answer 2 laws of rinsing fire, tide water under bends with iron wire, and of such a length that they come to about a quarter of an inch from the top of the crucible. When the lobes are inserted, add a cover of 5 to 10 grams. Salt carefully bed and crucible in a good coke fire, and build the coke well above the thin edge of crucible. Place cover on the crucible and few lumps of coke on the covers. Keep the fire between dull red and bright red, that is a red, and never let it rise about a bright red. The time of fusion varies with the fire and all but at the end of the 10 minutes, the cover may be removed and the charge inspected, now when replacing the cover and coke after inspection. When fruiting cases, allow the charge to remain in the furnace for 5 minutes, then to pour into a hot, grease conical mold after withdrawing the wire lobes, any adhering fils of lead being removed by washing the wires in a slug. If the top of edge of the crucible have cooled below a red heat, the charge should not be poured. The bottom in the case removed by breaking the crucible when cold. This is a slug. Hammer the bottom into a cube and with it. Note the result and all details of firing, etc. Calculation of result. The percentage is obtained by multiplying the weight of the bottom in grams by 10. Accuracy of results, a difference of option exists unto the methods of this and of the kind of methods. Neither is accurate of the gravitic estimation. Second method, cyanide. Apparatus as before. Reagent, potassium cyanide salt. Details without any duplicate the following. Or the 10 grams, cyanide 30 grams, salt cover about 5 grams. Mix charged cover and insert the furnace as usual. Fuse for 15 minutes between a red and bright red, firing as before. Pour and wait with the bottoms. With a fairly clean Galena boats, methods give result with an error plus or minus of 1 unit. Example, if the gravitic process gives 75% of lead, this process will give from 74% to 76%. On the whole, the evidence is slightly in favor of the cyanide methods, but before proceeding further, the student must continue his practices till his results are uniform and satisfactory, even if he has to run 12, 30 or more assays. The time so employed is apply repeat by the confident gain. The following tabulation indicates the causes of the inaccurate calculation as before. Accuracy of result, here again practice, and care as necessary. With a clean rich galena, good results are obtained. But when impurities such as copper, antimony, bismuth, etc. are present, the results are worthless. To prove this statement, let the student add to one of his charts either antimony or copper, and then examine the result button. From this, student will gather that before assaying a stranger lead one, he must examine it qualitatively for this or similar substance. If this be present to any extent, fire methods must be replaced by weight processes. Zinc assay. All zinc confined are either solubles in or are decomposed by boiling with acids. The zinc going into solution, zinc forms only one series of salts, and these are colorless. Their Schiff's characteristic is solubility in an alkyne solution, from which sulfurated hydrogen procedures. A white precipitate of zinc sulfide. Zinc is detected by solving the substance in hydraulic or nitric acid, boiling, and adding solid hydrate and excess, filtering, and other ammonium sulfide to the filtrate. The precipitate contains the zinc, which can be dissolved out by boiling with dilute sulfuric acid, and detected by formation of a wort precipitate on the addition of potassic ferrocyanide. Dry method. The dry acid of the zinc can only be made indirectly, and as active as story. Zinc is boiled light, and at the temperature of its reduction is a gas. It is impracticable to condense to the vapor so as with the metal. Consequently, its amount to determine by loss. The following methods give us approximately result. Take 10 grams of the dried powder and rub the rust, first at a low temperature and afterwards at a higher one, with the half or carbonate of ammonia to decompose the sulfides form. Cool and wait, the metal will be present as oxide mixed with 2 grams powder charcoal and charged into a black lead, crucible heated of whiteness. Cover loosely and leave the furnace for about a quarter of an hour. And cover and calcine the reduce, cool and weight. The looser the weight multiple by 8.3 gives the percentage of zinc in the ore. Wet method. Solution and separation may be affected as follows. Treat 1 or 3 grams of the substance with 10 or 30 cc of hydraulic acid over aqua regia. Evaporate to dryness. Take it up with 10 cc of hydraulic and acid and dilute to 100 cc. Heat nearly to boiling. Saturate with the sulfide hydrogen. Filter and wash with water acidulated with hydraulic acids. Boil off the sulfurated hydraulic and precipitate with a few drops of nitric acid. Add caustic soda till nearly but not quite neutralize and separate the iron as a basic acetate by the method described under iron. To the filtrate, add ammonia till icon and plus sulfurated hydrogen. Allow to settle a descent on the filter Dissolve the precipitate from the filter with hot dilute hydraulic acids. The solution will contain the zinc together with the manganese, the ore contained, and perhaps traces of a nickel and cobalt. If the zinc is to determine voltammetry and manganese is present, this later is separated with carbonate of ammonia, as described further on. But as the gravitic method is used and only small quantities of manganese are present, it is better to proceed after they were absent and to subsequently determine its amount, which should be deducted. Apparatus and reagent, as before with addition of 4 nails or lobes of wire. Details about assay, without the duplicate following charge, the ore sample and cross as before, or 30 grams, red lead 20, soda 30, borax 10, charcoal 1 grams to 0 grams according to trial. As a primarily mix, diffuse one charge using no charcoal, examine the result bottom, nothing with. It is too small a bottom is obtained and suspension reducer to bring down to the required lead. It's too large another nail or a wire loop. The assay proper is conducted as before, the fire being kept at the dull red for 5 to 10 minutes and then at a bright red for another 20 minutes. The nail or wire are washed and removed and the charge pure, and the remainder of the operation and the calculation are conducted as usual. Accuracy. From data available, it seems that methods gives the results when applied to ores containing less than about 20% AFS2. Only a certain amount of SSFS can be dissolved in the slag, and any rise above the saturation point result in the formation of a regulus in addition to the lead bottom. The addition of the more iron only partially remedies this evil, so that the scope of the method is limited. B. Instrumentation methods of analysis. Spectrophotometry. A spectrophotometry method of determination of a small amount of copper in tungsten metal powder using the principle of solvent extraction has been developed. The metallic sample is dissolved in hydraulic peroxide, tartaric acid added, the physics adjusted, and the excess peroxide destroyed by boiling. Copper is reduced to the copset state and the reagent nitroperoxine 229 dimethyl 1 10-pentanthroline is added to form a colored complex with the copper. This colored complex is extracted into coform and the absorbance of the separated coform layer measured in the spectrophotometer. Copper contents as low as 1 ppm parts per million can be determined. The method is limited to finely divided tungsten powder. The interest in developing more sensitive methods for the determination to trace impurities in high impurity tungsten promoted an investigation of the possibility of using solvent extraction colorimetric methods. The organic reagents now commercially available make possible many extremely sensitive colorimetric methods for determination of metallic ions. Extraction of the colored complex into the small volume of organic paste can be used to furnish increased sensitivity. This general approach has the added advantages that no special equipment beyond the normal found in analytical laboratory required. X-ray fluorescence and X-ray diffraction. X-ray fluorescence, the prepared sample is specimen excited by the reagent of an X-ray. This causes an electrons form the inner electron shell to get knocked off. Electrons from other electron shell drop into the field resultant avoid emitting a fluorescence reagent's characteristic in its energy distribution for a particular element or materials. This fluorescence radiation is counted measured by the detector. Genre of XRF X-ray fluorescence radiation is shown below the simplest. 1. Electron from the key shell is knocked. Second, resultants avoid are filled by either an electron from the L shell or an electron from the M shell. Meanwhile, the key E and key B radiation are generated. which are characteristic of the particular elements capable of XRF measures. X-ray diffraction (XRD) is, is the non-destructive test method to analyze the structure of the crystalline materials. XRD is often used to identify mineral and metal compounds within a solid materials, verify material composition, or to identify the source of unwanted deposits. The XRD analysis process. Samples are typically submitted as a solid mineral or powdered form. Solid materials are mined or ground to a mined powder and placed on the sample stage. X-ray diffractions pattern are proceed by geonometer, which are rotated at specific angles while bombarding the sample materials with X-ray. Diffractions pattern bricks and syncytes are determined by the solution of the atom within the lattice. The X-ray diffraction pattern is specific to the period atomic arrangement in the given material, which compared to the ICDD standard database of X-rays diffraction pattern to the phase identification. Capabilities. First, identification of powder metal and mineral compounds. Second, quantification to primary and monetary crystalline phases. Third, quantification of preferred orientation. Fourth, measurement of residual stress in metals and ceramic. Lastly, measure of the crystalline size. Difference between XRF and XRD. The difference between XRF and XRD is simple. XRF analyzes for chemistry, while XRD determines the mineralogy. XRD identifies the mixture presence and the amount of the mineral and their species in the samples, as well as identify phases. XRF will produce and the assay by giving information on the chemical composition of the sample without identifying what phases they present in your sample. X-ray fluorescence, XRF, and X-ray diffraction. XRD analyze provide qualitative and quantitative materials characterization for detection, identification, analysis, quality control, processes control, regulatory compliance, and screening for metals and alloys, mining and geology, scrap and recycling, environment and consumer safety, education and reach, and general manufacturing. Microanalysis. Microanalysis is one method to use observe pure size directly after magnifying the sample. The pure structure in the section of the sample is observed with a certain magnification. The pure numbers and size can be measured in the field of view with standard scale, and the pure size and distribution can be calculated, in which one pure distribution is the percentage of the pure numbers in different pure size ranges. Pure samples with smooth section are prepared, and in the pure numbers within a specified length can be read throughout a microscope or a projector. A average score length is obtained to convert the average pure size. Most pures are not specific, rather they are irregularly poetical. As a matter of convenience, they are taken as expressed with diameter, and the following equation can be derived. Microanalysis is the statistical method, and there must be enough pure observation in order to obtain representative results. Analytical microanalysis of the sectional pure size distribution has been introduced. Within the given optimal image, the section area as per each pure can be taken as the area of the circle with a diameter of dp. However, the obtained dp is uncertain due to the possible tilt to the plane with pures.